which leaves 2 of these left over. And my final answer is 4 flats, which is 442. Does everybody see how it works? So this is using base 10 blocks. By the way, you wouldn't start with 3-digit numbers with your students. You would start with 1-digit, right? You'd do the same thing with 1-digit numbers, then you would move to 2 and finally to 3 and so on. But in each of those, there's going to be what we call a spectrum of going from concrete to abstract. Okay, here's the process. Are you ready? Base 10 blocks is your first method. Your next method, you're going to get a place value mat with base 10 blocks. So after they've done this, these blocks can be anywhere you want on the desk. I happen to write them so that the 400s were on the left, but they could be over on the right. Right? They're still hundreds no matter where they're at. So what I want to do is I want to next get a place value mat where this is the ones, the 10s, and the 100s. And I'm going to put my 264 here. And I'm going to put my 178 here. And then I'm going to what? Put them together and make some exchanges. Let's put these 3 with these 7 and exchange it for another block. Let's put these 8 with these 2 and exchange it for another rod. And now my answer is what? 4, 4, and 2. Now how is this and this, how are they alike? Well, they both use base 10 blocks. How are they different? Over here, they could be anywhere. Mixed up. My answer could look like this. I could have the 2 here, I could have the 4 things here, and I could have the 4 others over here on this side. It doesn't matter, right? This is 442. But when I do place value, it starts putting them in the same order that we do with our numbers. So it's getting more abstract, but it's still hanging on to where we're at. What's our next stage? You'll notice that a rod looks very different than a flat. I can tell that's a flat by looking at it. I can tell it's 100. Very visual, very concrete. I can tell this is 10. If I forget, I can actually count the little blocks that are glued together. When I move to this stage, instead of using the base 10 blocks, I'm going to use counters. So now 264 becomes 2, 6, 4. And 178 becomes 1. Now, why do we want to move them here? By the way, you do hundreds of problems with the blocks before you do this. Then you do hundreds with this. Then you move to here. You don't just, I'm doing it all in one day. And I'm doing it with 3-digit numbers. Don't start with 3-digit numbers. Start with 1 digit and do the same process with 1 digit. So that by the way, if you look at the Common Core and the trajectories that they have, that how you move through these, the curriculum will have that all outlined, what grade does what and when. But this is the process. Now what do? I say I know that 10 of these make up one of these. So I take these 6 and add them with these 4 and say bring that over and make it one of those. And I know that 10 of these make up one of these. So I'm going to grab that, and my answer is 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2.
So is it like that sheet thing we did?
Yes.
Okay.
We exchanged when we got to 4. Your kids are going to be exchanging when they get to 10. Yep. So place value mat with counters. The next thing we're going to do is we're going to do the instructional algorithm. So we're going to get even more abstract, but not completely to where you were taught to do the standard algorithm. I'm going to take 2, 6, 4 plus 1, 7, 8. And I'm going to start on the left. And I'm going to say 2. That's not really a 2, it's a 200. And I've been reinforced with that because it was 100 here and here. And now it's 100 because it's in the hundreds place. And now that's how I know it's 200. So 200 plus 100 is 300. 60, I know it's a tens because it's in the tens place. 60 plus 70 is 130. And 4 plus 8 is 12. By the way, I could have started on the right and done it the same way. I'd have the 12 up here and then the 130 and then the 300. Does everybody see what I'm doing? These are called partial sums. Partial sums because I haven't added up the whole thing. I've only added up part of it. So these are partial sums, and now we're going to get the grand sum, the big sum. And I can do that for 2. Okay, this is the instructional algorithm. Have I carried anything? No. I'm ready to do that now. This is the instructional algorithm. This is what we call the standard. This is the way most of you learned how to add the numbers. You start on which side? Always the right. Your teacher taught you right. So we go 4 plus 8 is 12, and we write a 2 and write the 1 up there. The interesting part about it is now they will know what that 1 is. How will they know? Because it's this one right here. And it's that one right there that we exchanged. It's this one here. And does everybody see how? They'll know what that means. You know what most elementary teachers do? They start right here. And the kids don't have a clue what that little 1 up there means. No idea. So you need to move them from concrete where they understand what's happening until it is clear to them as they come across this spectrum from concrete to abstract. Now I add 1 plus 6 is 7, and 7 is 14, so I put a 4 here and a 1 up here. And again, they'll know what that 1 is because of what they've done here. It's this one that I'm going to add to these other 3. Okay? So I have a 4. This is the standard algorithm. This is where we want every student to get to. We don't want them having to add with blocks every time they do an addition problem. First of all, you get into great big numbers. That becomes really inefficient. Okay? Or, even with 3-digit numbers, if I give you 8 3-digit numbers, that's a lot of blocks. You'd have to consolidate a lot of sets, and you'd have a big... You could get the right answer. But why do we have the standard algorithm? It's very efficient. It's very short. But don't start with it because students have trouble. Now, in tonight's homework, you're going to be asked to go across and do this, but you're going to be asked to do it in another base. If you will start at the concrete and just say, okay, I'm going to draw myself, it's base 5. I'm going to draw myself, here's 1. A rod would have 5 of those in it. And my flat would be a what by what? A 5 by 5. Right? And I'm just going to, and if you'll do that, and then come to this one, and here, and there, you're not going to have trouble adding. Why are we throwing you in another base? I've had students accuse me of it's to torment 205 students. That's not it. You said it. We know base 10, and we know how to make these little marks. But you don't know the other bases. And so you're going to have to do the same thing your 2nd and 3rd and 4th graders are going to be doing as you do this. It's going to create empathy for your students. When they're struggling with base 10, you're going to go, I remember when I struggled with base 6. I know why they're doing that. They're having problems. And if you can do base 6, guess what? You understand base 10, and you understanding base 10 will allow them to do base 10 better because you're more capable of helping them out. All right. Now, that's addition. What's the name of this unit? Addition and subtraction. Here we go. 264 minus 178. I'd like you to use the blocks. Come across from concrete to abstract and do each one of these for this. And I want you to use the takeaway model. Okay, don't use the comparison model. Use the takeaway model. Takeaway model.